Very exciting time for NASA, very exciting time for Orion. Been working on this for a long time and really looking forward to where we're going to go on this mission just 24 days from now, headed back to the moon. So it's just amazing. So let's go to the next animation. We've got some graphic here to kind of explain the pieces of the Orion the Orion vehicle. It's made up of three main elements. Is there an animation that we can show?
Yeah, let's see.
There we go. Okay, thank you.
Yeah.
So made up of three main modules, the crew module, the launch abort system, and the service module. So you've heard the crew module also referred to as the command module. That's that silver capsule there in the center. The silver surfaces you see are our back shells. It's made of about 1,300 silica tiles, very similar to what we flew on the bottom of the shuttle during the shuttle days. And it's covered in some paint and some Ciox tape and aluminum tape to help with thermal protection. So that's kind of what you see there on the outside. On the bottom of the crew module, you'll see the heat shield that we've talked about being one of our primary test objectives on this flight. It's 16.5 feet in diameter, so it's the biggest heat shield we've ever built. It ablates some material away as we re-enter. The crew module also has its own small propulsion system. It's got several reaction control system jets that perform those type of maneuvers that Rick alluded to on the re-entry when we have to orient to the right orientation before landing. Parachutes, 11 total parachutes that you just saw pictures of that deploy in a very time sequence to slow the vehicle down from about 350 miles per hour down to less than 20 when we hit the water. Which Reed will be happy that we're at that speed hitting the water. Pyrotechnics throughout the vehicle. We talk about, jettisoning things like the launch abort system or the service module when we're done with it. We use these pyrotechnic devices that help make those vehicle separations. And then when you go inside the cabin, you've got your environmental control and life support systems, so everything that controls pressure, temperature, and humidity inside the volume. That crew module is designed to hold 4 crew members for 21 days, and so obviously on Artemis 1 we're flying uncrewed. This is our test flight, so expect to learn a whole lot about how all these systems work. Inside the vehicle also there's avionics systems, our guidance, navigation, and control, communication systems, which are a lot different than the GPS you probably used your map to get here today. It doesn't work outside of the distances we're going, so we're using a deep space network kind of system for our communications. And then several payloads that we're flying on this flight, several of which are in the crew seat location. So we won't be flying crew, we'll be flying some mannequins and some torsos that are simulated human tissue and organs that are looking at radiation protection, radiation environment, the acceleration of the vehicle, and how that affects the human body, because our goal is for the crewed flight on Artemis 2. For future crewed flights, won't be on this mission, but we'll be adding in a waste management system, a galley, and exercise equipment, all for crew health and comfort and safety during the mission. So we can go to the next slide. So this is the crew module and the service module located in our factory at the ONC. This is before we install the launch abort system. Artemis 1, as you know, we're testing all these systems and capabilities, and this will be the kind of configuration of the vehicle that will be available mostly during the mission that we're talking. One of the main objectives you've heard is about the heat shield, and so the heat shield is, the vehicle comes back at about 25,000 miles per hour, and we end up at temperatures of about 5,000 degrees Fahrenheit, which is about half the temperature of the surface of the sun. So we're talking about very high temperatures we're trying to protect for. We have a block design for this heat shield. It's made up of these Abcoat blocks that are adhered to a skin and a skeleton, and we'll be testing that as one of the main objectives. But of course, when you look at the spacecraft, we talked about some of the other objectives as well, and you can see the solar arrays here folded up against the vehicle. We'll be doing what's called the modal survey of those solar arrays once they're deployed, and looking at how they respond to different jet firings, engine firings, to make sure they can handle the vibrations and the loads that they'll see throughout the mission profile. Checking out all of our guidance and navigation and control, and then obviously the parachute systems as we come back in. Okay, next slide. So next picture is the vehicle as it came into the vertical assembly building there at KSC. So it looks a lot different now. We've got the fairings around the crew module and service module, and we've got the launch abort system mounted on top. So the launch abort system, I didn't talk about that previously. It's designed to pull the crew capsule away in case there is an emergency on either the launch pad or during the ascent phase. So it's made up of 3 solid rocket motors. The first is the abort motor, and that's what actually pulls the crew member away. Very powerful. It goes from 0 to 400 miles per hour in 2 seconds. So talking very quick, really trying to outrun an SLS that might be having an issue during launch. At the top of the last system is the attitude control motor, and that's what's used once it is separated from the hazardous event. It steers the crew module away and allows it to get to a safe location. And then finally the jettison motor, which would jettison the launch abort system from the crew module. So on Artemis 1, that jettison motor is the only active motor. We don't plan on using the other functions. This is a non-crew flight, so we didn't put those motors on the vehicle. But the jettison motor is the one that works every flight. So it's either, eventually you take the last off, whether you're in a nominal flight or in an emergency situation. Okay, I think we can, let's see. We can go to the next slide. So this is a picture of us rolling out to the pad for one of the wet dress rehearsals. Before we got to this point, every component, every system, every module on this spacecraft has been thoroughly tested. We've done over 48 engine tests between the aux engines and the main engine that we talked about to make sure we have a robust propulsion system. That parachute system that we showed, 25 different drop tests that we did, chunking capsules and lawn darts out the back of military aircraft, making sure that we can handle every parameter, things like chutes out or different wind conditions, wave conditions, looking at all of that through that test program. Literally thousands of hours of avionics and software testing in the laboratories here at JSC and at Denver, where our Lockheed Martin prime contractor is located. And then we took the entire spacecraft to a thermal vacuum chamber up at Glenn Research Center, the Armstrong Test Facility, and it spent over 47 days in that chamber, just really wringing it out, testing every aspect of the temperatures that we'll see, the vacuum, the pressures, acoustics, and so really have spent a lot of time testing this at the component and module level. If you've been following Artemis for a while, you also know we did 3 flight tests. We've done 2 complete flight tests of our launch abort system. So one was a pad abort 1, which was looking at performance from a pad escape, and one was the ascent abort 2, which was looking at it during that very dynamic phase of the ascent. And then finally we had our exploration flight test 1 that happened a few years ago that tested out most of the crew module systems, and obviously we've added things today, and then we've also added our service module. Okay, I think we can go to the next slide. So here we are on the pad. This is the last picture we took before we rolled back into the VAB, and I just love this photo. It gives me chills to see this moon in the background, our destination sort of calling to us. Just a huge amount of collaboration, testing, and energy and effort that's gone into putting this together. We had over, I'd say 3,000 to 4,000 suppliers in every state of the United States. So really just a huge effort across our country. Also have a very strong partnership with our Europeans on the European service module. So didn't talk a lot about the service module. Our Philippe Delou, who's the manager of the service module program, is online, so I'll be handing over to him to let him talk through the details there. But we're rolling out on the 18th and just looking forward to this flight and everything that we'll be learning from it. So Philippe, if you'd like to talk through the service module, that would be great. Thanks.
Yes, thank you.